For more information on tutoring, personalized video solutions, or how to support Moof University and the production of more videos, please visit moofuniversity.com. Thank you and enjoy.
So at this point, I'm hoping you're beginning to notice that elements in the same group have similar electron configurations. And I kind of want to touch on that in this video. The group 8A elements, the noble gases, which are right here, kind of pulled that up over here, all of their orbitals are completely filled with electrons. Okay. In fact, all of them, except helium, the first one up here, all of them have an outer configuration of ns2 np6. Helium doesn't have the np6, it's just ns2. Okay. And because they're completely filled, their orbitals, they are very stable. They are very stable and they're not reactive. Chemical reactivity is based on what's going on with electrons, and because these things are filled, they're really, really stable and unreactive. The group 1A elements, the alkali metals, including hydrogen as well, they have an outer configuration of ns1, and they are very reactive. In fact, they tend to form a +1 ion, all of them. And that's specifically a cation. Cations are positive ions. So H forms an ion to become H+, Li forms Li+, Na forms Na+, potassium K+. So for them, why they do that is because losing one electron gives them a completely filled or stable noble gas configuration. Okay, and so they all have similar reactivity because of their similarity in their electron configuration. The group 2A elements, the alkaline earth metals, they have an outer configuration of ns2. And they are somewhat reactive. They're pretty reactive, I'd just say somewhat relative to the alkaline metals because they're super reactive. They tend to form a +2 ion, also a cation, positively charged. So like Mg2+, Ca2+, so on and so forth. For them, if they lose those two electrons, they have a completely filled and stable noble gas configuration, okay, which is why they tend to form that ion. The group 7A elements, the halogens, they have an outer configuration of ns2 np5, and they are very reactive. They tend to form a -1 ion, which is an anion. Anion is the term applied to negatively charged ions. So fluorine would become F-, Cl-, Br-, I-. And for them, they're one electron away from having a perfect noble gas configuration. But they have to gain an electron. So they gain one. They gain a negative charge, and that gives them a completely filled, stable noble gas configuration. So that's the ion they tend to form. Now on your own, I would encourage you to give the outer configurations of the group 5A and group 6A elements. Try that on your own and describe the ions you'd imagine them to form. That might be a good exercise to do on your own. But I hope you see that these things have similar chemical reactivity because chemically, in terms of their electron configurations, they're very similar. Hope that video was helpful. Thank you for watching.
If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you and happy studying.